this video, we're going to talk about how to fill in this foldable that I gave you guys in class. It was on bright yellow paper. And what you're going to do is you're going to fold these outside edges, the outside edges in until it meets this center line. So it looks like you have two door flaps. And then you're going to cut on this line. It's just going to be a cut about like this and about like this to make two little door flaps. And if you need help with the cutting and the folding, just come see me and I'll show you what I mean for that part. What I'd really like to focus on right now is just filling in the bits and pieces of this. This is all things we've talked about in our notes. And this is how to use this, how to graph using this equation for absolute value. So the first one that we're going to graph is f of x is equal to the absolute value of x. And remember we talked about this is called the parent function. And you can write that in down here on this space because this says transformations, and that means how did it move from the parent function? Well, since this one is the parent function, there are no transformations for the parent function itself. Now, each one of these, it asks you for the domain and the range. Remember, the domain is the x values, and range is the y values. Well, for domain, since x can be any number, any negative, any positive, it could be 0, our domain is all real numbers. We know that it continues to go on forever to the left as it goes up, and it goes forever to the right as it goes up. So all of the x values, every number on the number line is used. The range, however, that's when we look for a high point or a low point. And you'll notice here on the parent function, we have a low point right here. The entire graph of this absolute value is above that point. Well, this point has a y value of 0, so our range is y can be anything greater than or equal to 0. So that one is our parent function. On the next one, here we have f of x equals -2 times the absolute value of x. So I went ahead and put the parent function on there for you so you can see the comparison. We see that there's no addition or subtraction in this one, so there's no h and no k. That means h and k are both 0. So this graph starts at 0, 0. Now we notice that it's negative. So we see that a is negative, and since a is negative, we know it's going to be a reflection in the x-axis. That means it's going to open down. It's going to look like this. That's a reflection in the x-axis. And we know that it has a is 2, so it's going to be a vertical stretch by a factor of 2. Remember that if your value of a is greater than 1 or it's less than -1, it's going to be a stretch. If it's in between -1 and 1, that's when it's a shrink. So that -2 also works kind of like a slope for us. So we're going to go down 2 and over 1 in each direction, down 2 and over 1 in each direction, and we could continue that pattern. Oops, that's not a great line. There we go. The domain for this one, again, is all real numbers. And the range for this one, since this time it has a highest point, and that highest point is at the origin, and everything for our equation that we graphed is below that, all the y's are less than or equal to 0. Okay, in our next one, we have some more transformations. We do have an h and k in this one. The -3, that's where our h is, and we know that that moves us left or right. And the -2, that's k, so that moves us up and down. Now, when it's inside that -3, remember, we move opposite the direction that we see. So that says -3, so we're actually going to move +3 to the right, and then the -2 moves us down. So we're going to go right 3 and down 2. And then we do have a vertical shrink here with our factor of 1/2, and it's positive, so it'll open up. We're going to rise 1 and run 2 in either direction. Oops, that should be out here. And we're going to have kind of a wide graph right there. So let's see, our domain is all real numbers. Our range, we have a low point again, and our low point is at -2, so y has to be greater than or equal to -2. Our transformations, we have a vertical shrink by a factor of 2. We have a horizontal translation to the right 3, and we have a vertical translation down 2. And then for our last one, we have a horizontal translation in here, we have a vertical translation out here, and we have another vertical stretch by a factor of 2. And we see it's negative, so we know that it's going to open down. So that +1, that's going to move us to the left, and the +3 is going to move us up. So our vertex is at -1, +3, and then we're going to go down 2 and over 1 since our vertical stretch is by a factor of 2. Here's our graph. Our domain is all real numbers. This absolute value has a high point where y is 3, so y is less than or equal to 3. And then our transformations are many, right? We have a reflection in the x-axis. We have a vertical stretch by a factor of 2. We have a horizontal translation to the left 1, and we have a vertical translation up 3. And that just gives you kind of an idea of all the different types of absolute value functions that we graphed, and hopefully you can use this as part of your notes.